so I don't forget. Okay. Remember. Oh, that's good. All right, so you got your test back. Like I said, these are going to come back for the final exam, so keep it to study from and whatever. Like I also mentioned, I think I posted the solutions already. I can't remember. If I haven't, I will post them after class, so don't worry. Overall, it was pretty good. Not as good as the test 2 usually is. So just kind of as a group, but makes me feel like it's my fault. So I'll try to bring you guys up for test 3. All right. So anything else that I wanted to mention? We started chapter 6 last day. We're going to keep going with chapter 6 and hopefully polish it off. And then we've only got 2 more days of new material, which is crazy, right? But we're going to do chapter 7 in 1 day on Thursday, chapter 8, which is only 1 section on mortgages, on Tuesday next week. And then we'll have a review for test 3, and then we'll have test 3, and then after that we'll just have final exam review days for 2 days. So pretty good. And like I've been saying, everything that's on the final you'll have seen in a test situation on test 1, 2, or 3. So let's do a little bit of review because it was a while ago, right? So we started chapter 6, which was annuities. Right. And so an annuity is when we're making or getting just regular payments, right? So the same equal payments at regular intervals. Annuities are when we're making or getting, they behave the same way. Equal payments at regular intervals, right? So for example, most common examples are things like car payments, mortgage payments, and then on the flip side, right, if you get your pension, right, you retire and you get your pension, it's going to be some equal amount that you get every month, let's say, right? And so that's also an annuity. And so mortgage payments, car payments, right, or your pension. Right, those are just examples. Right? Regular payments at, or equal payments at regular intervals. And so what we said was, okay, so we can have ordinary annuities or annuities due. And so an ordinary annuity, I'll clean this up a bit. Annuity is just when payments are being made at the end of each payment period, right? At the end of each month, at the end of each week. Payments are made at the end of each payment period. So if we break it up into chapters, right, this is chapter 6. And then the flip side, we can have an annuity due. And that's when the payments are made at the beginning of each payment period. Payments are made at the beginning of each payment period. Right. Which is what we're going to get into in chapter 7. Like I said, we're only going to spend a day on chapter 7 because it only changes things ever so slightly, right? Because now let's say we're making interest or paying off interest just a month earlier or a week earlier than we would have, right? So we need to make an adjustment, but it's going to be pretty minor, right? All the ideas stay the same. And so that's why we spend some time in chapter 6 where we talk about ordinary annuities, and then chapter 7 is just a little special case. Okay. We said, okay, well now we're on the flip side. For simple versus general annuities, it's simple. It's a simple annuity if the payments per year equals the compoundings per year. Right. And it's a general annuity if the payments per year are not equal to the compoundings per year. Hopefully everyone's okay if I use those abbreviations. It just saves us a lot of writing. Right, and it matches what we have on our calculator, right? So, but what we said was, just to be on the safe side, if we're doing an annuity calculation, let's just treat it like it's a general annuity and assume that these are not the same. And then if they turn out to be the same, then fine, right? Then we can just stop working on that, right? Because what we had to do, right? So if we have a general annuity, we need to find I2. I'll put in brackets and use it, and use it in place of I before we can do any calculations. And we spent a lot of time last day talking about this, right? Because what happens is, okay, so we want to make monthly payments, let's say, right? But if we're compounding quarterly, right, 4 times a year, then the easiest thing for us to do is to change our periodic interest rate, I, to be compounding monthly instead of quarterly, right? So we move from quarterly to monthly. And so we use I2, and this is your go-to formula out of all these 5 I formulas up at the top on your formula sheet. I2 equals 1 plus I1 to the power of F1 over F2, and then minus 1. Where I1 is, it's not letting me do anything, is the original periodic interest rate So that's the one that we've been finding so far for compound interest, right? We have to find I before we can go ahead and do any calculations. Now we have to find I1, and then we have to find I2. Where F1 is the compoundings per year. F2 is the payments per year, right? We're moving from F1 to F2. Right? And so that's how you can remember, okay, well, F1 is the compoundings per year. I want to change that to match the payments per year. And then I2 is the periodic interest rate. With compoundings, with compounding frequency, I should say. That matches the payment frequency. Yeah. And then we said, okay, well, if I take out a loan, right, then I've got some present value and I'm trying to pay it off with my payments. At the end, if I'm all done, there should be no future value, right? Same idea. If I'm starting with nothing and I'm making payments to save for some future value, right? I've started with nothing. And so if you look on your formula sheet, right, we've got a formula for the future value and a formula for the present value. And they don't appear in each other's formulas. So it depends on what you're looking for is going to tell you what formula to use, right? And so we started and we said the future value is the PMT, and then in big brackets, 1 plus I. That I is going to be your I2, right? And last day we said, right, that if F1 is F2, right, if the compounding frequency is the same as the payment frequency, then I1 equals I2. And so there's no harm done in trying to find I2 and realizing that, oh, it didn't change, right? But that's the safer way to do it. So 1 plus I to the power of n minus 1 over I, right? See, no present value in there. That's okay. Because then we've got our present value looks about the same. We've got the PMT, which is the payment amount, all times 1 minus 1 plus I to the negative n over I. Where PMT, right, is the payment amount, I is I2, and N, because we've made our compoundings match the number of payments, it's going to be easier to think of N as the number of payments. Technically, it's still the number of compoundings, right? But you don't want to trip yourself up. And so N in your calculation, because it assumes that you've converted your interest rate, right, your periodic interest rate to match the payment frequency. And so N is going to be the number of payments, number of payments So we'll do a little example, example 210, just to get in the groove. Okay. Hank borrowed money from Tank. One question. Hank agreed to make yearly payments of $2,500 for 12 years. If Hank charges interest of 13% compounded annually, what was the amount of the loan? First thing I want you to do, right, is, well, sort through, you know, what we're given and all that fun stuff. But one of the first things I want you to do is figure out what your payments per year and what your compoundings per year are, right? If they're the same, then you don't really have to find I2. I will, just to show you that it ends up being the same thing. But first thing I'm going to do here is say, okay, well, my compoundings per year, compounded annually, is 1, which is going to be my F1, just as a rule. And my payments per year, he agreed to make yearly payments. So again, it's 1. Just to be safe, right? I want your first step to be finding I2, right? Once you get into the rhythm of things, right? If you see something like this, then you can say no need to find I2, right? But once we've seen enough of them, right, then that'll start kicking in. But I hate to see especially on test 3, by the final, everyone's kind of on board. But on test 3, a lot of people forget to calculate I2, so I want to put that safety mechanism in, right? And so for I2, remember, is 1 plus I1 to the power of F1 over F2 and then minus 1. I1 is R over, we can call them R1 over F1. We have 13% compounded annually. And even if you say it out loud, right, going from compounding annually to compounding annually, right, you don't need to change anything. But as we'll see here, and as we saw last day, it actually doesn't change anything if we do the calculation, right? So we do 1 plus 0.13 to the power of 1 divided by 1 and then minus 1. So we've got 1 plus 0.13 and then minus 1, right? Because that's all to the power of 1 over 1, which is to the power of 1. So that just goes away. And then we have 1 minus 1 plus 0.13 leaves us with 0.13. All right. I'm going to say, since F1 equals F2, there was no need to solve for I2. Since I2 equals I1, but it's best to start here to be safe. Okay. We made some changes to the timeline if we have annuities, right? Because now we've got these regular payments. And so what I said was, for these timelines, I want to see the first 3 ticks and the last 2 ticks, right? And so we've got, okay, he's going to make yearly payments for 12 years. So we can start our timeline, and we'll start it today. And it's going to go for 12 years. He's going to make yearly payments. And so if I want to see the first 3 ticks, that's today, and then at 1 year and at 2 years, right? And then I can just stop. So 1 year, 2 years, and then what I'll do is just put ... to indicate that, hey, things just keep going, same way. So I want 3 at the beginning and 2 at the end, right? And that'll be able to show us what's going on. So 12 years, the previous payment would be at 11 years. Right. Same rule as always. I want the dates up top, right? And then the amounts down below. And then I want arrows going in whichever direction, right? Present value or future value that we have to solve for. So let's see here. So Hank borrowed money. Okay, he's going to make yearly payments of $2,500 for 12 years. So that means at the 1-year mark, he's going to make a payment of $2,500. At the 2-year mark, $2,500. Right? These amounts don't change. If we're borrowing money, right, and we're paying it off, if we have to find how much money we borrowed, that's going to be the present value, right? Because how it's always going to be kind of like an interchange, right? So I borrowed money and then I'm paying it off until I've got nothing owing, right? Or I'm paying money until I've got some amount that I can take out, right? And so money's always kind of switching back and forth, I guess. And so if we want to know what was the amount of the loan, right? If you have to know what the amount of the loan is, that's always going to be a present value. So how do we indicate that for annuities? We just take all these and we funnel them together, and then we pull all these back to today to find some present value. And the present value is the value of the loan. On the arrow, just like before, I'm going to put n, but n now is the number of payments, right? Which means that n is time times f2, right? Which is the payment frequency. They're the same in this case, right? But we've got t is 12 and a payment frequency of 1 per year, so we've got 12 payments, which fair enough, right? We could just map it out. It gets harder though if we have to do, 30 years of biweekly payments, right? It's not as obvious to count them out. So we want to establish some way to calculate them. But as long as you remember that you have to use F2, right? Use F2 since n is the number of payments. And now let's use I2, it doesn't matter, is 0.13. We already calculated it, but it's nice to summarize it all in one spot. Oh. Okay. This is your complete timeline. We're solving for PB, which means we have to use our formula sheet, and once this loan is all paid off, right, the future value is going to be 0. So that one we don't care about. Right? So we use the present value formula. PB is the PMT times 1 minus 1 plus I to the negative n all over I. PMT is that regular payment amount of $2,500. 2,500 times 1 minus 1 plus 0.13 to the negative n. N is 12. And then over I, which is 0.13. As you saw on the test, right, I is not always a nice number. And so you'll have to store the number on your calculator. I don't want to see any rounding. Okay. In this case, it is 0.13, so it's safe. So how we're going to calculate these, right, to be mathematically correct, right, we're going to start inside these little brackets, 1 plus 0.13, and then that to the power of negative 12, and then 1 minus whatever we found, right? So you could use the store function just to be safe, and then divide it by 0.13, and then multiply by 2,500. These are a pain to write out the different steps. So if you just wanted to go straight from here to the answer, that's fine, right? As long as you've shown me what you're going to use, then you're safe. Okay. I'll do the one check-in point, but not much else. 1 plus 0.13 to the power of 12 negative. 1 minus that divided by 0.13. I get this, so 2,500 times 5.9176477017. So make sure that you get the same thing. And then our answer should be 14,794.11754, which, if we're rounding to money, we need 2 decimal places, 14,794.12 pennies. Nice. I guess that was all review. Put a little end of review squiggle. Any questions though? It was a while ago. There was a long weekend in between. It happens. I'll start on a new page then. All right. 6.3, just like before, right? We're going to dissect this formula. But what kind of happens is we're going to solve for PMT and N. But as you'll notice on the formula sheet, there's two functions for N. And that's because we have a function for the future value and a function for the present value. And depending on what value we have, that's going to tell us which N formula to use. So 6.3 is calculating the periodic payment so solving for PMT and number of payments and solving for PMT isn't that crazy, right? Depending on if we know the future value or the present value, you're going to use that formula, plug in all your values, and solve for PMT, right? There's no PMT formula on your formula sheet, but that's because the work is pretty simple. So we'll start solving for PMT. If we know the future value, then plug in all the given values into the future value formula. Future value is the PMT times 1 plus I to the n minus 1 over I, and solve for PMT. Right. I'm just going to highlight that if we know the future value, you have to use the future value formula. That's not that crazy. Same idea, right? If we know the present value, whereas if we know PB, use the present value formula as the PMT times 1 minus 1 plus I to the negative n over I. And solve for PMT. All right, so again, if we know PB, you have to use the PB formula. More? Here, probably, I think. Because here is where we ended. Quite all right. So we're just going to do an example with one of these, and then you can do it with another one, right? Because the methods are the same, right? And so if we do example 212, let me see here. Your RSP goal is $300,000. The current interest rate for RSPs is 8% per year compounded annually, and you intend to retire in 30 years. How large should your year-end contributions be? Okay, so first thing I'm going to do is I'm going to figure out, okay, well, what's my compounding frequency and what's my payment frequency? We're not doing anything drastic here, so they will be the same, but it's always good to start and check there. And so we're compounding annually. Oops. Compounding annually, so the compoundings per year is 1. That's going to be our F1. And how large should your year-end contributions be? So the payments per year that I'm making is 1, so F2 is 1. I1 is R1 over F1, which is 0.08 over 1, which is 0.08. Here I'm just going to make a note that since F1 equals F2, since F1 equals F2, we know I2 equals I1, which is 0.08. So I'm not going to solve it again because it's going to end up being the same thing. So my I that I'm going to use is 0.08. Okay. This is a kind of a flip situation of what we just saw, right? What we just saw was, okay, we get a loan, a present value, and then we pay it off with our payments. Now we're making payments. So we're starting with nothing, and then we're making payments until we have some future value. Right? we're told that that future value has to be 300,000, and then we have to find what the payment amounts should be. So our timeline is a timeline for an annuity, blah, 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 an annuity. So I'm going to start today, just arbitrarily, and I'm going to retire in 30 years. I'm making year-end contributions, and so, but I only want to see, I want to see 3 ticks, at least 3 ticks in the front and 2 ticks in the back. That's the bare minimum. And so if I'm making annual contributions, well, then I'm making a payment at 1 year, at 2 year, ... at 29 years, and at 30 years. These payment amounts still go underneath the ticks, right? Just like we had X when we were solving for the unknown payment amounts before, right now we're just calling them PMT because they have to be the same. So we've got a payment, a payment, a payment, and a payment, and payments in between, right? These payments all have to funnel into some future value, which we're forcing to be 300,000. Because I'm drawing the arrow forwards, it's becoming a future value, right? Whereas if I'm drawing it backwards, it's a present value. On the arrow, I still have N, but N is going to be the number of payments. And so N is going to be time times F2. Time is 30 years times F2, which is 1. So I have 30 payments, which makes sense. If I'm making annual payments for 30 years, I need 30 payments. And recall that we're using I2 as 0.08. Just kind of off to the side somewhere. Okay. So now I have everything that I need in order to solve for the payment amount. I know the future value, so I know I have to use a future value formula. Right? So the future value is the PMT all times 1 plus I to the power of N minus 1 over I. Plugging in our values, right? The future value has to be 300,000. I'm trying to solve for the payment amount. So I'm just going to leave that as is. Times 1 plus 0.08 to the power of 30 minus 1 over 0.08. So I'm going to simplify the big brackets and then divide them over to the left-hand side to solve for PMT. So I've got 1, so I have to start inside those big brackets. I have to start in the little brackets and then bloom my way out. So 1.08 to the power of 30 and then minus 1 divided by 0.08. So I have 300,000 is the PMT times 113.2832111. Make sure you don't round anything. We are dealing with money, right? So it's kind of important. And so PMT, if we're solving for it, has to be 300,000 divided by 113.2832111. Oops, probably not that last one. There. 300,000 divided by the previous answer, I get a PMT of 2,648.230016, which we have to round to 2 decimal places because it's money, 2,648.23. All right. Any questions about that one? Pretty good. All right. So now let's see. So calculating the number of payments n, right? Which is how we would find time, right? Just as before, right? We had to find I in order to find R, and now we had to find n in order to find t eventually, right? And so this is our gateway to finding how long it's going to take to pay off a loan, for example. We have to figure out how many payments we need, and then convert that into time. On your formula sheet, right, we're on to the new step. We've got, and remember for chapter 6, we're only focusing on the left-hand side, right, for future value, present value, and the perpetuity, which we probably won't get to today. We've got 2 formulas for n. Which one we pick just depends on if we know the future value or the present value, right? And so nothing crazy. The first one has the future value, the second one has the present value, right? And so if we know FV, the future value, we use n is the natural log, so ln of 1 plus I times the future value over the payment amount, all over, I know I'm bad, I call it the log, the natural log. For me, there's only one log, the natural log, the log of 1 plus I, but it's ln. Again, right, future value. Whereas if we know the present value, we use, and it looks very similar, right? So you have to keep your wits about you. N is the negative log, or ln, of 1 minus I, so slight change, times the PV over PMT over the natural log of 1 plus I. And again, PV and the PV. So depending on which value we know, that's going to tell us which formula we have to use to solve for n. All right. Let's do example 216. Let's get crazy. Maxwell borrowed $20,000 from loan shark Alec. Sounds like a bad idea. Alec demanded year-end payments of $3,500. How long will it take to pay off the borrowed money if Alec charges 17% interest compounded annually. Okay. So we're not getting into the deep end with different payment and compounding frequency, but we're going to get there, right? And so we have to keep in mind that that could be changing soon, right? So we're just going to get in the habit of figuring out, okay, so we've got year-end payments and interest compounded annually. So again, I'm just going to make a note that the compoundings per year is 1, which is our F1, right? The compoundings per year is always our F1, and the payments per year is also 1, and the payments per year are always going to be our F2s. I1 is R1 over F1, which is going to be 17%, so 0.17 divided by 1, which is 0.17. I'm just going to make a note here that since F1 equals F2, we know I1 equals I2, which is 0.17. Otherwise, if they weren't the same, we would have to find I2, right, before we could go ahead and do anything. All right. So we've got a loan that we're paying off, right? And so that loan, that's the amount that we get today, let's say, and then we're paying it off with payments. And so loan amounts are always going to be present values. And then if we're saving up some amount, that's going to be a future value. So what does this look like on a timeline? Well, we're going to start today. And we want to know how long is it going to take to pay it off. We know we're going to make yearly payments, right? And so here at 1 year, 2 years, right? I want to see the first 3 ticks and the last 2 ticks. So N is the number of payments, right? And we're making yearly payments. And so I can translate that into this question mark. I'm just going to move it up. Must be N years, right? We're trying to solve for N. And the second to last tick must be N minus 1 years. We know how much we're paying each year, right, at the end of each year, of $3,500. And so underneath each of these, at the end of each payment period, I pay $3,500. And this is all to pay off some present value today. So the present value, which was $20,000, right? I borrowed $20,000 and then I'm paying it back for some amount of time at 17% per year at $3,500 per year. My guess is it's going to take me a while. So on the arrow, I'm going to put N, but remember N is the number of payments now, so time times F2. We don't know time, right, but we know F2. I'm just going to put a question mark here for now, right? We're solving for N, and so we don't know what it is. But we should still have it on our timeline because that's where we highlight everything that we're trying to solve for. And then we've got I2 is 0.17. So that's our complete timeline. And now we can figure out which formula to use, right? We've got the present value is 20,000, so I have to use the formula with the present value in it. So we've got N is the negative natural log of 1 minus I times the present value over the PMT all over the natural log of 1 plus I. We know all these values, so we can just plug them in. We need the negative log of 1 minus 0.17 times the present value is 20,000 divided by 3,500. And then divide that by the log of 1 plus 0.17. Shouldn't be sloppy. Bed math, or I can subtract it from 1. So I've got 20,000 divided by 3,500 times 0.17, and then 1 minus that. Oops. I don't know what happened. I pressed the wrong button somewhere. 20,000 divided by 3,500. So I need the negative natural log of 0.028571429 over the log of 1.17. If I take the natural log of this, I get negative 3.555348061. I'm going to store this in 1. And then I'm going to have 1.17, and then the log of that is 0.157003749, which I'm going to store in 2. I'll just make a note to myself here. So to calculate this, I'm going to do recall 1, but then negative of it. That's just to get rid of the negative, right? We're always going to have a negative value there. So the negative out in front is just to get rid of the negative. Right? We're never going to have a negative n, right? So that should be a checkpoint for you. And then divided by recall 2. So I get an answer of 22.644988834. Just like before, right? I can't make 0.64 of a payment, right? 22 payments isn't quite going to pay me up, right? And so I need to make 23 payments, right? And so we would need to make 23 payments, or I should say annual payments. So it will take 23 years, I'll say, to pay off the loan. If I asked you what the difference was between how much he paid and how much he borrowed, right? How much interest did he pay? how much interest will, what's his name? Will Maxwell have paid? Okay, so he's making 23 payments of 3,500. So he pays 23 times 3,500. So it's costing him $80,000 or $80,500. He borrowed 20,000. Right, so the total interest paid must be 80,500 minus 20,000, right? That was the amount of the loan, which must be $60,500. Kind of scary. I guess the message is don't borrow money from a loan shark, especially loan shark Alec. But I mean, 17% are, I think if your visa is usually like 19 something, 20 something percent. So pretty similar. Although I think you'd be more motivated than $3,500 a year to pay it off. Nice. Any questions about that one? So like I said, we're only going to do the one where we know the present value, but where we know the future value looks the same, right? It behaves the same. We have to find all our values and then plug them in, solve for n, remembering that n is the number of payments. Okay. So now I've kind of been prepping you for general annuities this whole time, right? But section 6.4 is for ordinary general annuities. So general annuities, just as a refresher, general annuities are when the compoundings per year are not equal to the payments per year. Need to find I2 before we can do any calculations. Which we've been kind of pretending to do, but it hasn't been necessary until now. All right. So let's get right into an example because there's nothing new here, right? It's just that additional first step of finding I2 is really important. So example 218. Oops. Suppose month-end payments of $300 are made on a car for 4 years. If the rate of interest is 5% per year, compounded quarterly, what is the value of the car?
Yeah. And so now I've got my compoundings per year is 4, which is my F1. And then I'm making month-end payments. The question is emphasizing that the payments are at the end of the payment period, right? Because next day we'll have payments that could be at the beginning, right? But for now, all the payments have been at the end, and they will be at the end until Thursday. And so month-end payments means that we have payments per year of 12, right? Monthly payments, which is going to be our F2. If it helps, right, I do them in alphabetical order, right? Compoundings per year, payments per year, and that might help you remember that F1 and F2 belong to compoundings and the payments, right? In case it's not obvious. Since F1 is not equal to F2, we need to find I2. So first thing we're going to do is we're going to find I1. I1 is R1 over F1. I1 is just how you would have found I in compound interest problems. So 5%, so 0.05 divided by quarterly, which is 4. So 0.05 divided by 4, I have 0.0125. Bless you. So now I can find I2 is 1 plus I1 to the power of F1 over F2 minus 1. So we have 1 plus 0.0125 to the power of F1, which is 4, divided by 12, and then minus 1. BEDMAS, we have to move from inside the brackets out, right? So we have 0.0125 probably on our screen still, so I'm just going to add 1. And then to the power of, and when I do the power of 4 over 12, I'm going to put the 4 over 12 in brackets just to ensure that they're all in the power, right? So to the power of, and then 4 divided by 12, and then minus 1, right? Otherwise, what would we be doing? If we left it at 1.004, we'd have 100% per month, which doesn't make sense, right? And so that's why we have to have the minus 1. So minus 1 is 0.004149425. You have to store this, right? I don't want you to be typing it in every time. And also because the calculator actually knows more decimal places than it's showing, right? So sometimes there's going to be little discrepancies if we just use the values that I write on there. And so I'm going to store this in 1. All right. Good chunk of work done. Now we can map out our timeline, right? And so we're making month-end payments of $300 for 4 years. If the rate of interest is 5% per year compounded quarterly, what is the value of the car? So remember, we essentially got a loan for the car and then we're making payments. So the value of the car is the present value. So today, and then for that last tick, I'm going to write the 4 years just up above because I'm actually going to have ticks every month, right? Because that's when I have payments. And so I've got 4 years up above here, but 4 years is 48 months. And I'm making payments every month. So I start today, and then I'm here at 1 month, 2 months, ... up to 47 months. Oops. And then 48 months, right? I want to see the first 3 and the last 2, at least. But there's no reason to do more than that, as you'll see. So I'm making payments of $300. So those payment amounts go down below. And if I want to know the value of the car, that's the value of the car today, right? And so we're going to funnel all these back to today, which means I need to find the present value. PV is the value of the car today. Right. How much did you buy it for? We're still going to put N on the arrow, even though we basically had to calculate it for the top of our timeline, right? But just to emphasize, we've got N is time times F2, which is 4 times F2, which is 12, which is 48. And then recall that I2 is stored in 1. I'm cheating, but you're allowed to do that, right? Because I showed all my work up above. And so I'm just going to say, hey, I already calculated I2. It's stored away in 1. Okay. So now we have to find the present value. We can go ahead and use the present value formula, right? As long as we use, in place of I, we have to use I2. Right? So we've got the present value is the PMT times 1 minus 1 plus I to the negative N all over I. Uh-oh. Makes my pen so glitchy though. I'm gonna have to plug it in. It's okay. So we're solving for the present value. We know the payment amount is $300, right? Making month-end payments of $300 times 1 minus 1 plus I. Should I start cheating right away, or what do you guys think? Instead of writing out I2 every time, right? I'm just going to write recall 1. Because I've said I'm storing it in 1, so as long as you've told me where you've stored stuff, you can just use recall whatever. Yeah, I'll start cheating right away. Recall 1 to the negative 48. And then that's all over recall 1. See, it makes my pen all glitchy when it's plugged in for some reason. Okay, so then we get to work, starting inside the little brackets, inside the big brackets. So 1 plus recall 1 to the power of 48 negative. 1 minus that divided by recall 1. Just so you can check your work,
Although if you went straight from here to the final answer, that's fine by me.
I get 300 times 43.44063287. So times 300. So then my present value is 13,032.18986, which if we're dealing in money, right, we want 2 decimal places, 13,032.19. Any questions about that one? So the timeline looks a little bit different. We have to find I2 before we can go ahead and actually do any calculations. But, I mean, nothing new under the sun, really. Section 6.5 is using the calculator for annuities, right?
We used our calculator for compound interest, but you'll definitely find it helpful for annuities. Mostly because it calculates I2 for you. Nice.
Recall,
we had a list of calculator inputs, right? And so, especially on test 3 and on the final, right, as you get more used to working with your calculator, right, to show your work, because we're used to showing our work with all our calculations and all that fun stuff, right? To show your work, you just list all your calculator inputs, right? So I want to see these inputs, and that's equivalent to showing your work and doing all that work by hand.
So recall that to show our work,
I swear it's because it's plugged in. I don't know what happened there.
does weird things. See, it goes all weird. Okay. To show our work, if,
hey, it just wants to have a line there.
So weird. If we are using our calculator, we need to list all our inputs, and I want them in this order. And the writing's getting harder and harder to read. In this order.
Oh, that's nasty.
Also indicate the value you're solving for. You are solving for with an asterisk.
And just to highlight which one are you solving for, right? And then I can look and say, okay, well, these inputs are all good. It should get you the right answer.
So we said, and before when we introduced working on our calculator, right, we listed all the possible inputs, and then we said, well, some of these don't really apply until later, but now this is it, right? Except for the beginning or the end mode, which we talked about. So N is going to be the number, oh my goodness, the number of payments. Can I survive off 5% till the end of class? This is so annoying. You might be pleased to know that I probably could. 5% away? I know, exciting, right? Well, here we go. Talk a big talk. Is the number of payments, right? Whereas before N was the number of compoundings, but now it has to be the number of payments, just like in our calculations. And then listing them in the order that they appear on our calculator, right? The interest per year is the nominal rate as a percentage, right? And so for 7%, we just use 7, right? Not 0.07. That would mess up your calculations. Next one over is the present value. Well, that's just the present value. Then you've got the PMT, which we know what it is now. That's the payment amount. Remember before, when we didn't have any regular payments, we just left it as 0, right? We just entered 0. But now we're going to have some payment amount. So we'll be able to enter that. And then we've got the future value, which is just the future value. And then in the second menu, remember we go to the payments per year and the compoundings per year, right? So we've got the payments per year, P per Y, which is the payment frequency. Payment frequency, which just remember is your F2. And then our compoundings per year, well, that's the compounding frequency. Which is our F1. And then the last option that we listed was the beginning or the end mode. Now that we know a little bit more about annuities and knowing that we could make payments at the end of the month or at the beginning of the month, for example, then we're going to be able to adjust for that in our calculator, right? But for now, we're going to deal with ordinary annuities, which are at the end. Ordinary annuities is the end, whereas annuities due is at the beginning, right? In general, this is when our payments made. At the beginning or at the end. For now, right, we're just at the end. In fact, unless it explicitly says payments are made at the beginning of each month, right, they're going to be at the end, right? The default is the end unless it explicitly says the beginning. So now, remember how we had to have different
signs for the present value and the future value, right? One had to be positive, one had to be negative. Before, it didn't really matter which one was which. But because we're going to have situations where we're borrowing money and then we're paying it off, right? If we're getting money, remember we said we'd make that positive, and if it's leaving our hands, we make it negative. Because if we make both our present value positive and our payments positive, that means that we're getting some loan amount and then we keep getting those payments, right? So then at the end we have this huge future value, which we don't really want, right? That's not what we're going for here. And so money leaving our hands will be negative and money coming to us will be positive. So you just have to imagine, just from your standpoint, am I getting money or am I leaving, or am I getting rid of money, right? It's hard to think of, okay, so if I get a loan, right, but then that means that I'm getting money, right? And what we're going to imagine is that if I paid money, so I paid $200 a month for 20 years, and then I want to know the future value, the idea is that I'm paying, $200 a month or whatever, and then that future value I would take out and get that money, right? So money's leaving me, and then I get it back. So let's do example 218 on our calculator. That's the one that we just did. What's nice is that we know the answer that we got, and so we can check our work. So we've got our list and interest per year, present value. And so you don't have to really memorize them. You can just look at your calculator, right? Most of those are in line on your white buttons. So, and interest per year, present value, PMT, oops. PMT, future value, payments per year, compoundings per year. And then just because I've got a page break here, I'm going to scoot these up one to make room for beginning or end. We've done a lot of this work already, right? So we know that N was 48. The interest per year, now that's that original interest that was in the question. So R was 5% per year. And so what we have to use is just 5. The present value is what I'm solving for. So remember, we put a little star by what we're solving for. Maybe I spoke too soon. 2%. My battery's just dwindling. So the present value, that's what I'm solving for, right? So I'm just going to put a little asterisk there. And now for the payment amount, right? I know the amount is 300, but I have to imagine whether it's leaving my hands or coming to me, right? And so if I'm paying off a loan, right, then I'm making payments of $300, right? I think it was $300, yeah. And so it's going to be negative 300. Money is
leaving my hands, right? And so it's negative.
Just like with the formulas, right? The future value in this case is going to be 0, right? I get some loan amount, the present value, and then I pay it off. At the end of all that, I should have 0 left owing, right? If I want to figure out, okay, well, how long is it going to take me until I have this much left owing? That would be your future value, but that's not something that we're going to get into. So the future value is going to be 0, right? I'll just say will all be paid off. Oh. And then we said the payments per year, now I can't remember, but I've got them here, were 12, and the compoundings per year were 4. And for the beginning or the end mode, right, we're at the end. And you can just double check that you're at the end. If you go second PMT, it has the BGN over top, and it should just say end, right? If it's at the beginning, it would have a little note up at the top, even if you're not in the BGN screen. All right, so we haven't done a ton of work on our calculator, right? But for these white buttons, all we do is we figure out, okay, I have to put 48 into n, so you're gonna have 48, and then you hit n, and it should just end up saying n equals 48. And then we keep going, so 5 into the interest per year. I'm gonna skip the present value because I'm gonna come back and compute it. And then, so then I'm gonna have 300 negative into the PMT, 0 into the future value. And now I have to go into the second menu for the payments per year, which I'm gonna be forced to be 12. To save it in the payments per year, you have to hit enter after, and it should change it to be payments per year equals 12. And then you can scroll down, and same thing for the compoundings per year, you have to have 4, enter for it to save. And then you can exit out of that, so second, quit. And now you're gonna go and compute, so hit CPT and then PV, so it'll compute the present value. So I get, I'll just do it in a different color just to indicate that that's the one I solved for. I get positive 13,032.18986. What did we find earlier? When we did it by hand, we found 13,032.18986, right? So we get the exact same values. Even if you find that you're a little bit off, if you're checking your work, for example, which I encourage you to do, something might have happened, right? And so you'll want to make sure, because it will end up being the exact same answer. Usually just a little rounding error somewhere along the way, right? This present value is positive, right? Because I got that loan amount and then I'm paying it off. Nice. How about example 219? Oops.
Okay. Notice how the calculator, and I think I mentioned it already, but the calculator finds I2 for you, so it saves you quite a bit of work. You still have to show your timeline, right? But you wouldn't have to calculate I2, and you'd have to just show your calculator inputs. So although it's annoying to list all those, it's not that hard. Still need a timeline though, regardless. All right. Do you want to do this one by hand and on the calculator, or just on the calculator? We've got options. Thanks, Josh. Great. Let's do it. Tom and Delilah wish to start a college fund for their daughter. Their goal is to put $200 into the account at the end of each 2-week period. So that's bi-weekly, right? And so here our F is 26. Assuming the college fund will earn a rate of interest of 3.75% compounded quarterly. So now the compounding frequency is F1, which is 4, which means that the 2-week period, the payment frequency is F2, which is 26. I'm going to do exactly what I did before, right, and just highlight these below, even though if we're just doing it on our calculator, it's going to be in the list as well, right, but it's just good to have an overview. Because we could just as well do this one by hand. Maybe that might be a fun thing for you to do this evening on your own time. So fun. The compoundings per year we said are 4, which is going to be our F1. The payments per year is 26, which would be our F2. Since F1 does not equal F2, whoa, it's just as surprising every time. We would need to find, oh my goodness. We would, it's like, we would need to find I2. But since we are using the calculator, just let me get this out. Using the calculator, we won't need to. Now, in the past, we won't need to. I've actually made calculating I2 part of the timeline, which means that you would have to calculate I2 if you're using your calculator. But most people were forgetting it, and do they really need it? No, not really. So I've decided to, if you're using your calculator, you don't have to show I2. All right. So we still need a timeline though. And so their goal is to put $200 into the account at the end of each 2-week period. And we've got 3.75% compounded quarterly. How much will be in the account in 20 years? And so we've got, they're going to start today, let's say, and end in 20 years. I'm going to put 20 years up above just because I know I'm making bi-weekly payments, right? And so 20 years is equivalent to 20 times 26 is 520 bi-weeklies. I'll just use BW. Mm. $520. Oh, sorry, 519. Going backwards. It's hard, I guess. 519 biweeklies. Today, 1 biweekly, 2 biweeklies. Dot, dot, dot. Right. At least 3 in front and at least 2 end payments. They're going to make payments of $200 at the end of each biweekly period. And at the end of it all, right, if we're thinking about should these values be positive or negative, right, they're making these payments so it's leaving their hands. At the end of it all, they'll have some future value that's going to come to them. So, oh, that was sloppy. Hard to erase when they're all, oops. This is going to be some future value. And N is time times F2, which is 20 times 26, which we already found was 520 payments. So here's our timeline. They start with nothing, and then they're going to have some future value that we're going to calculate. Or actually, the calculator is going to find for us. We need to put in N, the interest per year, the present value. No. The PMT, the future value, the payments per year, the compoundings per year, and whether it's beginning or end, which I'll shorthand to B/E. We already found N is 520. The interest per year is 3.75%, right? So in our calculator, we're just going to use 3.75 because we have to use just the pure percentage, but without the percentage. The present value is 0, right? They start with nothing. And they're making payments of $200. So that's $200 that's leaving their hands. So it has to be negative. I'm trying to find the future value, so I'm going to put a star there and come back to it. And then I've got my payments per year, which is 26. And the compoundings per year, which is 4. And I'm in the end mode. So if I go ahead and I plug these in, 520 into N, 3.75 into the interest per year, 0 for the present value, 200 negative into the payment. Skipping the future value, I'll come back to it to calculate it. The payments per year is going to be 26, enter. Compoundings per year has to be 4, enter. And then I'm going to compute the future value. So I get, and I'll just use a different color just to indicate this one I calculated, 154,476.0202. So therefore, after 20 years, they would have $154,476.02. Dun, dun, dun. How much did they pay to get that? They paid $200 times 520 payments. So they paid $104,000 to get $154,000, basically. So they made a lot of interest. Nice. So you can go ahead and you can calculate that one by hand, but it's a lot easier to just use your calculator. Any questions? Oh. So that is, there's just a tiny little bit left of chapter 6 perpetuities that we'll do next day because it's really fun. But until then, that's it. See you guys on Thursday. And if you didn't get your test back, you can come grab it now.